Welcome back students to my channel. Today we are going to discuss about the second law of motion. What we have here, Newton second law of motion. So before starting this, I want to tell you that in last lecture we have talked about the linear momentum. So what is the symbol for linear momentum? P. How P is denoted as product of mass and velocity. Okay. So to understand now to the second law of motion, first we will consider a situation. Suppose what we have here a car. What we have here a car. Now suppose the battery of this car is dead. Okay, this is dead battery car. So if we want to start this car, what we need to do? First, suppose you can observe from this picture that this man is pushing this car. What is that push? What is that push we call? That push is nothing but he is applying the force on the car. So the car will not start moving instantly. It will take some time. It will take some time. This means we need to apply this force for a certain period of time. After this required time, the car will begin to move. Okay. Now, why this is so? Question is why? Because the speed of car will increase from 0 to 5 meter per second, say. Okay, so this means that change in momentum is produced. Why change in momentum? Because this velocity is changing from 0 to 5 meter per second. If the velocity is changing, momentum is what? Mass into velocity. If velocity is changing, momentum is also changing. So this means that change in momentum is produced by applied force. Okay, so this change in momentum depend not only upon the magnitude of force but also the duration of time during which the force is applied. Clear, student? The change in momentum which is here we are observing in this situation is depend upon two things. What two things? The magnitude of the force, and the another thing is the time during which the force is applied. Now from here what we are getting, students? From here we are getting the Newton's second law of motion. What the Newton's second law of motion says, the rate of change of linear momentum, the rate of change of linear momentum of a body is directly proportional to the external force applied on the body. So this only we are doing. We are applying force. What we are doing, students, here? We are applying force. Because of the force, okay, which is applying at a certain period of time, there is a change in velocity. So because of the change in velocity, the momentum will also change. So this is nothing but the Newton's second law of motion. What it states that the rate of change, okay, which thing will change, of linear momentum is directly proportional to the which thing, external force applied on the body. What is this meaning of directly proportion, students? Directly proportion means more will be the force, more will be the change in the momentum. Okay, both are in direct proportion. If one thing will increase, other thing will also increase. If force will increase, the momentum, the change in momentum will also increase. What is the meaning of rate? Rate means we are considering the force which are we are applying it, we are considering it in a particular certain period of time. So if I want to write it in this in other words, how I will write that this second law of motion says that change in which thing, linear momentum is not upon time taken, upon time taken. This is the meaning of rate of change. Rate means we are considering this change in linear momentum with respect to time. Change in linear momentum with respect to time upon time taken is directly proportional to the force applied on the body. Okay, so this is a sign of proportional, students. Force means more will be the force, more will be the change in the linear momentum of the body. Okay, so this is nothing but a Newton's second law of motion. Now if I want to write it in the mathematical formulation, how I will write, let's see this also. They can ask you in long questions this type of question that drive the mathematical formulation of Newton's second law of motion. So for this we will take any body whose mass is m. What is m, students? Mass of the body. Okay, then we will take u. What is u, students? Generally we will take u as a initial velocity. Okay, initial velocity of the body. Okay, initial means starting of the body. Clear? V is what? V is the final velocity of the body. Okay, final velocity of the body. Clear the terms? What is m? Mass of the body. What is u? Initial velocity. V, final velocity. T. T is the time period. What is T? Time period during which we apply the force. Okay, time period for which we apply the force. Generally students get confused in these terms, that's why I am explaining them in detail, that m is the mass of body, u is the initial velocity, v is the final velocity, and the t is the time period. Clear, student? Now what will be the initial momentum? Okay, initial momentum, very easy. Momentum is nothing but a product of mass and velocity. So what is my mass here of the body? M. What is my initial velocity, students? Initial velocity is what? U. So it is mu. What will be my final momentum then? Again product of mass and velocity. Mass will be same, mass will not change, m. What is my final velocity here? V. So it is mv. Any doubt? I don't think so there is any doubt, because initial momentum, it is very clear that it is a product of mass and velocity, and initial velocity is u, so it is m into u. Here it is m into v, the final momentum. Now change in linear momentum. Change in linear. Whenever we need to calculate the change, students, change in linear momentum. Whenever we need to calculate the change, we will do the subtraction. That is what, if this I will say p1, which is initial momentum, and this p2, then change will be what? P2 minus p1. So what is p2 here? Mv. What is p1 here? Mu. So mv minus mu is nothing but a change in linear momentum. And m can we take common? Yes, m is v minus u. Okay, now we want to calculate the rate of change of linear momentum, because this is our Newton's second law. New rate of change of linear momentum. Rate of change in linear momentum. This is very important derivation, students. Don't forget to revise this for your exam. So rate means, rate I already told you that when we are talking about rate, we will compare it with time. So it is upon t. T is the time period. Okay, now according to Newton's second law of motion, rate of change of linear momentum is directly proportional to which thing? Force. So can I write it? F is directly proportional to rate of change of linear momentum, v minus u upon t. Now the last step. What is v minus u upon t, students? V minus u is a change in velocity upon time. Rate of change of velocity is nothing but acceleration. So F is directly proportional to what? M V minus U can, what I will put here, V minus U is equal to A. So F is directly proportional to MA. Whenever we have to remove the proportionality sign, students, proportionality sign we are changing with equal to, then we will here write a constant K MA, and if this K is equal to 1, then F is equal to MA. So this is the mathematical formulation of Newton's second law of motion. So what this says, that force acting on a body is a product of two things, mass and acceleration of the body. Clear, students? Let's revise once again. Nothing, it is very easy, students. M is nothing but what we have here. M is what? Mass of the body. It is what? Mass. U is what, students? Initial velocity, starting velocity of the body. V is what? The final velocity. T is what? The time during which the force is applied. Now if we want to calculate initial momentum, so only thing we need to keep in mind, what is momentum? Momentum is mass into velocity. If they are saying initial momentum, then initial velocity into mass. Mass is always same, m. Initial velocity is what? U, mu. Final momentum means final velocity into mass, mass same, m. Final velocity is what? V. This p1 means initial momentum and p2 means final momentum. Now change, whenever we need to calculate change, it will be p2 minus p1. What is p2? mv minus mu. M is common, so we will take here common, v minus u will be remain inside. Now according to Newton's second law of motion, rate of change in linear momentum is what? Rate means we will divide it by which term? T. Now it is directly proportional to which thing? Force. So whenever we need to remove this proportionality sign, with the equal to sign, we will write here a constant K. One more thing, this V minus U upon T is nothing but a rate of change of velocity, which is equal to acceleration. So I will write this whole in is equal to A. So what we are getting, the second law mathematical formulation here, F is equal to MA, which is force acting on a body is a product of two things. What are those two things? Mass of the body and acceleration of the body. I hope this is clear to you. If it is clear to you, please don't forget to subscribe my channel. Thank you.